Hello again and welcome back. Today we're in section 1.3 of our statistics course, and we're going to be looking today at simple random sampling. So what I want to do is give you a definition for simple random sampling, and then I'm going to show you how to use a random number table to generate a simple random sample. And I will also show you how to get a simple random sample from your TI-83 or TI-84 graphing calculator. So let's go ahead and get started. First of all, random sampling is the process of using chance to select individuals from a population to be included in the sample. Okay, so let's remember that a population is all the individuals who are of interest to your study or experiment. And a sample is the individuals you're going to pull from that population. And the goal in statistics is to try to get the sample to be as similar to the population as possible. Now, the word random does not really mean in statistics what it has come to mean in everyday conversation. For example, I hear students say sometimes, I just ran into some random guy outside. And what they mean is they ran into somebody they weren't expecting, or they didn't choose the person or seek them out. But that doesn't mean that it was a random person. If that person is there by their own design, or they're there for some reason that you're not aware of, it's not a random encounter because it's not totally by chance. So just remember that random in statistics means completely chosen by chance. Now, for the results of a survey to be reliable, the characteristics of the individuals in the sample must be representative of the characteristics of the individuals in the population. So that's what I was saying before. Our goal is always to try to get our sample to be as much like the population as possible. And the key to obtaining a sample that's representative of a population is to let chance or randomness play a role in dictating which individuals are in the sample, rather than convenience. And we're going to see later in the next section that a convenience sample is never a good thing. If convenience is used to obtain a sample, then the results of the survey are meaningless. And what we mean by a convenience sample is one where the participants are chosen by ease of access, or maybe the participants choose to place themselves in the sample, sort of like one of those web surveys you see where it says click now to participate in this survey. Well, because those people are placing themselves in the sample, the results of that poll are meaningless as far as extending them to the whole rest of the country or whatever the population is supposed to be. Another example of a convenience sample might be if a student wants to get an idea of the average grade on the last test, and he asks his three buddies who sit next to him, what did they make? Well, the average of those three friends does not really give you an idea of the whole class, because those people are his friends for a reason, and they might all share some characteristic that determined how they performed on the test. So you can't use that kind of thing as a way to get an idea of what's going on with the larger population. Okay, so now we know a little bit about what a random sample is. Let's talk about a simple random sample. So here's the definition. A sample of size lowercase n from a population of size capital N is obtained through simple random sampling if every possible sample of size little n has an equally likely chance of occurring. The sample is then called a simple random sample. So notice that we use lowercase n to denote sample size, and we use capital N to denote population size, and that is a constant thing throughout the course. And so a simple random sample means that every possible sample of size little n has an equally likely chance of occurring. One easy way to get a simple random sample is to draw names out of a hat. Another way to get a simple random sample is like you see on the lottery on TV when they have the ping pong balls sucked up through the machine. That's also a simple random sample. But the idea is that every possible sample of size n has an equally likely chance of occurring. So now let's take a look at an example together We're not quite ready to draw our own simple random sample, but this example is just going to illustrate a simple random sample for us. It says Sophia has 4 tickets to a concert. 6 of her friends, Yolanda, Michael, Kevin, Marissa, Annie, and Katie, have all expressed an interest in going to the concert. Sophia decides to randomly select 3 of her 6 friends to attend the concert. List all possible samples of size lowercase n equals 3 from the population of size capital N equals 6. Once an individual is chosen, he or she cannot be chosen again. And that makes sense because she wants to give the 3 tickets to 3 different people. It wouldn't make sense to have somebody chosen twice. So they've already actually done this for us. We're not going to take the time to write down all these names, but let's look at the table. We have here Yolanda, Michael, Kevin, Yolanda, Michael, Marissa, Yolanda, Michael, Annie, Yolanda, Michael, Katie. So what they did is they took Yolanda and Michael and combined them with each of the other 4 people. Okay, then on the next line, they took Yolanda, Kevin, and they've already got Yolanda, Michael, Kevin, so they're going to now do Yolanda, Kevin, Marissa, Yolanda, Kevin, Annie, Yolanda, Kevin, Katie. Okay, and you can see that they continue going until they have every possible combination figured out. Now there are rules about how to know how many combinations are possible, and we're not really going to get into that in this course, although it is an interesting topic. But we do have here every possible combination. And notice there are no repeats. For example, the group Yolanda, Michael, Kevin is the same group as Kevin, Michael, Yolanda. So you don't see that group repeated in here anywhere. All right, so the question they're asking us is, how likely is it that Sophia will choose Michael, Kevin, and Marissa? Well, let's look. Michael, Kevin, and Marissa is right here. Okay, and there's only one group in here that contains those 3 people. And since there are 20 different combinations here, and only one of those contains Michael, Kevin, and Marissa, the likelihood of choosing Michael, Kevin, and Marissa is 1 out of 20. And notice that that would be the same for any combination that we cared to try it on. Every combination of 3 people has a 1 in 20 chance of being the group that goes to the concert. Okay, so we're working our way toward an example where we can collect our own simple random sample. So let's just recap a few things and maybe pick up another word or two. A simple random sample requires that every n individuals have the same chance of being selected. One way to conduct a simple random sample, like we said before, is to draw names out of a hat. That's impractical, though, if the population is large. Just think about what if you had to get a simple random sample on a population of 5,000 people, to write down every name, even if you could print them from a computer, to cut them all apart onto their own little slip of paper and put them in a hat or a bucket, would just be a waste of time, especially in the computer age. That's not really how we do things anymore. But that would be a simple random sample, although it would become pretty inconvenient at that size. Another way would be to use a random number table or a random number generator on a calculator or a computer. And I'm going to show you both of these, although the random number table itself is probably a little old-fashioned nowadays. Most people have easy access to a computer or a calculator that will do a simple random sample for them. So when we get to the end of the section, I'll show you how to do it on a calculator. Okay, a simple random sample requires us to have a frame. A frame is a list of all the individuals within the population. And sampling without replacement means no individual can be selected twice. So the example we did a while ago with the girl with the concert tickets, that was a sample without replacement. Because remember, they said that nobody could be chosen twice. Okay, so here are our steps for obtaining a simple random sample. Obtain a frame that lists all the individuals in the population of interest and number the individuals from 1 to capital N. And then either use a random number table or a graphing calculator or statistical software to randomly generate lowercase n numbers where lowercase n is the desired sample size. And I'm going to show you how to do this on a random number table and also on a calculator. And I'm assuming that not everybody in the class has statistical software, so we're going to leave that out. So here is our example where we're going to obtain our own simple random sample. It says an accounting firm wants to conduct a survey of 5 out of its 30 clients. Here is the frame. So every client is listed and everybody has a number. And notice that these clients that have single digit numbers, they actually went ahead and gave them 2 digits. So 01, 02, 03. That way every client in the frame has the same number of digits, and that's important. Now that we have our frame, we're ready to look at the random number table. And here is the random number table that's in our textbook. Every statistics textbook has its own random number table, and they're not all necessarily the same because there's no one table because the numbers are random. And you always have to remember that. So every book could have a different random number table and they could all be valid. And now here's the way the table is arranged. These are the random numbers, and the table is labeled by rows and by columns. And just for ease of readability, the columns are grouped into 5 columns per group. So they're labeled up here, column 1 through 5, column 6 through 10, 11 through 15, and so on. So like this 3 is on row 4 in column 11. This 7 is on row 10 in column 19. See, because I know that the last column is 20 in this group, so this next one must be column 19. So that's how the table is arranged. Now what we want to do is randomly choose numbers that we can match up with our frame. So remember that the largest number in our frame was 30, and it has 2 digits. So we'll need to take 2 digits at a time from the table. Now we need to randomly choose a starting place, because if you always started in the top left column, well, you'd get the same numbers every time. So you want to randomly choose a place to start. And if we really had a printout of the random number table on a piece of paper, we could maybe throw a pin onto the paper and see where the pin lies. But since we don't, I'm just going to choose a place for us to start so that we can all start at the same place. And we're going to start on row 15, column 11. So row 15, column 11, that's a 2, but remember that we need to take 2 digits at a time because every number in our frame has a 2-digit ID. So actually, I need to take 24. And the way we do this is we go down, taking 2 digits at a time all the way down. And when we reach the bottom of the table, we just go to the next 2 columns and up to the top of the table and come down again until we have as many numbers as we need. So there's our starting place, and we're going to go down the column and write down every 2-digit number, and we're going to discard any numbers that are larger than 30 because those don't have any matches in our frame. And then when we come to the bottom of the table, remember we'll scoot over 2 columns and go back up to the top. Okay, so our first number is 24, and 24 does have a match in our frame, so we'll keep that one. And then down the table, the next number is 80. 80 is too large, so we'll discard that. The next number would be 98, and that's also too large. And the next number would be 17, which of course is less than 30, so we'll keep that one. And the next number is 05, and so we'll keep that. That's going to match number 5 in our frame. And then 18. Okay, now we'll keep the 18. But now we're to the bottom of the table, so to continue, we'll go back up to the top and do the next 2 columns, which is going to give us a 48, which is too large, and then a 25, which is within our frame, so we can keep that one. Okay, so here are our 5 numbers. Now what we need to do is match these 5 numbers with the members of our population. So here, remember, is the frame that we started with, and here are the 5 numbers that we got from our random sample. So number 24 matches up with Spruce Landscaping, number 17 matches up with Moe's Extermination, number 5 is Chicago Locksmith, number 18 is Nick's Tavern, and number 25 is Robert Thor's DDS. Okay, so now they can contact these 5 companies and perform their survey, and there's no worry in the back of anybody's mind, well, how come we picked these 5? Do they like us or do they not like us? Or, is this somebody's buddy or brother-in-law or something? So we don't have that worry because we know that these were randomly chosen, so we have more reason to hope that they are representative of the population. Now, I think it was important for us to go through this exercise so you could understand what a truly random sample is. However, using the random number table is kind of a manual way of doing things. It's very low tech. And if you had a large population and a very large frame and you needed a very large sample, then pulling a sample by hand using the number table would be kind of a tedious task. So of course we have computers that can generate sort of a random number for us. And now I'm going to show you how to get a simple random sample from a graphing calculator. Okay, here is my TI-84 calculator, and if you have a TI-83 calculator that you're using, the steps on it will be exactly the same as the ones you're going to see me do here. Notice that out here to the right you'll be able to follow the key press history, and I'm going to try to guide you along here with this arrow. So first of all, let me tell you that because these are calculators, they cannot truly generate random numbers. What they do is they perform a series of calculations that's so complicated that no human could guess what number is coming next. So it appears to be a random sequence of numbers, but it's not really. And the way calculators do this is they start with what's called a seed. Now you can feed the calculator any seed that you want. And so if we all feed our calculators the same seed number, they'll all generate the same, quote, random numbers. And that's how we know they're not really random, because if they were truly random, we wouldn't be able to duplicate them. So what we're going to do is just make up a number to put into the calculator, and for no particular reason, I'm going to put in 156. Okay, now don't press enter or anything, but just 156. And now we need to tell the calculator to store that as a random number. So down here, at the bottom of the left column of buttons, you're going to press the store button. Okay, and then you're going to come over here to the math menu. So up, press the math button. And now you need to move the cursor over to the probability submenu. And we're going to use these arrow buttons that go back and forth. You could either hit the right arrow 3 times to move over to this menu, or you can just hit the left arrow 1 time. So I'm just going to hit the left arrow 1 time, and that activates the probability submenu. And this is the command that we want, this rand. So since it's already selected, you see, all we have to do is press enter down in the lower right. And now press enter again to make it execute. Okay, now you can't see that anything happened, but what it did was it stored 156 as the random number seed. So now we need to tell the calculator to generate for us 5 random numbers between 1 and 30. So to do this, we'll use the math menu. So again, press the math button. And again, left arrow 1 time to activate the probability submenu. And now you can either scroll down to the random integer function, or you can just press the number 5 on your calculator to activate that random integer command. And now what we need to do is tell the calculator that we want numbers between 1 and 30, and we need 5 numbers. So 1, 30, 5. And I don't want you to be stressing out about remembering how to do this. I just want you to go through it one time with me. Okay, so the calculator has generated 5 random numbers for us, and notice that they are all between 1 and 30. And so we could use these to go back to our frame and get another sample of 5 companies. And here's a little trick. If you wanted to get another sample of 5, but you don't want to type all of this in, there is a way to get the calculator to give you back the last command that you used. So if you'll go second, enter, and then press enter again, okay, it generates another 5 number sample for us. So what happens is when you run the random integer command, it saves a new number as the seed, probably one of these numbers. And then when you ask it to generate another sample, it has a new seed to work from, so you get a different sample. But if you fed your calculator 156 as the first seed, then you probably got the same 2 samples that I got. So that is how you generate a simple random sample on a TI graphing calculator. And probably any mathematical package, statistical software, Excel, any spreadsheet probably has some built-in random number generator. So you won't see researchers who are trying to generate a simple random sample for an experiment sitting around with a random number table and doing it the old-fashioned way or drawing names out of a hat. You would have a frame for your population, and you would have a calculator or some other technology that would generate the sample for you. And that's how this works.